let there be a I'll apply a force F. This is x-axis, this is the y-axis here. How I'm applying force? This force I'm applying. So let this be the theta. There are two ways I can do this problem. No? Instead of this, first I will resolve every time rather than going for this one. No? So shall we put, and there's a point of application P. So what I do is like I just calculate what is R perpendicular. This is the force F, and this will become R perpendicular. What is R perpendicular? Will be R sine theta. So what is the torque about O? Shall we write it as torque about O about Z axis? This should be equal to R perpendicular into F, perpendicular distance into force. So instead of going for calculating R, theta, angle between R and theta, directly I'll calculate what is R perpendicular. This will be R perpendicular, no? R perpendicular into F. So on what basis? So if I expand this, what do I get? R F sine theta. R sine theta, what you can write it as? R perpendicular. The magnitude, the direction, the best way of studying the problem, no? But sir, you have shifted the point. Actually, the point P should be here only. To make you understand, I just brought it here. Or we'll do one thing. Talk about only. This is. I think this will be much easier, no? R perpendicular to F. Or can we do another way? I'll resolve this force. A student, what happened? Instead of this, he will resolve the force. Rather than R, he will resolve the force. The same diagram. The force was acting. This is theta, this R bar. So I will resolve this F now. So this should be the angle theta. So when I resolve it, one force will be perpendicular, the other force will be along R bar. This is R, this will be F perpendicular, this will be F parallel. Try to see this angle, 90 degrees. No, what is the torque due to F parallel will be 0, no? Torque about O. We are discussing torque about axis passing through O perpendicular to plane. So torque about O, OZ, this should be equal to, shall I write directly R, F perpendicular. What is the angle between R bar and F perpendicular? Will be 90. This will be much easier, no? What is further? This is theta, no? What is F perpendicular? F perpendicular is F sine theta. F parallel is F cos theta. Both are same, no? What about torque due to F parallel? Will be 0 because F parallel is parallel to R bar. So torque due to F parallel will be 0. F parallel torque due to will be 0. I got this, you see, R F sine theta. You look at the other thing we did. Come for here. What is R perpendicular? RF sine theta. Both are same, no? Look at this particular thing. RF sine theta 90 degrees or R perpendicular F. And now when a problem comes, what you're going to do? Will you resolve R bar or F bar? I'll show complete things. The same diagram, no? So here what when I resolved force R into F perpendicular. In the first case, what when I resolved R, where this R bar, R perpendicular is called as moment of arm. It's a left to student, or no sir, I'll not resolve R or F directly. I'll calculate angle between R and F, then I'll use this formula. I think there are three approaches are there. You calculate R, you calculate F, directly calculate R bar cross F bar, take cross product. That's the one thing. Next, you know magnitude of R, you know magnitude of F, then calculate the angle between R bar and F, theta. Use this formula. Or calculate R perpendicular into F. Or else what you should do, calculate F perpendicular into R. You'll get that now. So four approaches are there. The one which you find convenient in the numerical, you have to pick up. Maximum will not resolve force. We'll try to resolve the distance only. The position vector only will try to resolve, so that easily you can write it, the equations. Getting the idea now? This R perpendicular is called as moment of arm. Very important in applications. We'll try to think in this way because we just want to come out of calculations. So therefore we are using this method. So all the cases torque is same. Yes, in fact, all these cases the torque setup is same. RF sine theta, RF sine theta. Here also, what is R perpendicular? Will be R sine theta. So either of approach, or directly shall I write only sir, I'm not interested in all this. I directly write in the vector form. Yes, carry on. Okay, this is about initial. So tomorrow onwards, we'll start with our numericals related to this one. Where you find a little bit difficult, I'll come with a different set of numericals. Means, what is the tomorrow's approach? Torque due to various forces. Torque due to tension, torque due to friction, torque due to normal contact, torque due to weight, torque due to pseudo force, because torque due to spring force. We have come across so many forces, no? How all these forces can set up a torque. And the body is in equilibrium. We are going to discuss now tomorrow rotational equilibrium under action of various types of forces. This is the background we are going to set up before entering the application of the rotation mechanics. Okay, try to revise. So today you spend time with a door. Try to analyze, try to apply various forces. So what is the conclusion? If a force acts parallel to axis of rotation, if a force intersects axis of rotation, torque setup will be zero. That's the conclusion. This, when you are at the door, no, keep these things in mind and analyze it. Okay, thank you all of you. I'll stop the class.
Thank you, sir.
Tomorrow I'll give an example of injury about Z axis. Yeah.
Thank you, sir. Thank you, sir. Sir, paper discussion will be there.